This session is on Samson 1/3 rule. Please look at the part 1, part 9 for better understanding. We will look at how to derivate formula and how to find the area of a continuous function. And we will solve one of the problem on Samson 1/3 rule. Please like, share and subscribe this particular channel. Come to Samson rule. To understand Samson rule, okay, first you have to understand what is meant by 1, 4, 1 quadratic, okay, approximation. What is it? First you have to understand. First I have to explain you what is 1, 4, 1 quadratic approximation. It is nothing but finding the area of a quadratic equation, okay, but that one will be finding a formula for Samson rule, okay. If you consider here the graph, there is nothing but x-axis, there is a y-axis. Consider this one as a function, a quadratic equation, such that f of x is equal to ax square plus bx plus c. Now we have to find the area of it. So if we consider this point as nothing but minus h, and this point as a plus h, and this is nothing but a 0, and the point here as nothing but y0, here is nothing but y1, and here is a y2. To find the area of it, we will be just integrating it from integration of minus h to h f of x dx. We know the value of x, so it becomes integral of minus h to h ax square plus bx plus c into dx. Just integrated, we get as a x cube by 3 plus b x square by 2 plus cx, and a whole from minus h to h. So just substitute the value, we get it as 2 times of a h cube by 3 plus here x square, right? So it gets cancelled. So we get it as well as a c into 2h, right? So which is nothing but whole integral of it, okay, which is nothing but the area of it. Now a and c value first would be find it out. What is c value? C is nothing but a constant, right? C is nothing but a constant term, right? It is constant at this particular origin only, so it is nothing but y1. So we can consider c is equal to nothing but y1. Again we will find the value of a. We know the value of an f at this particular minus h and plus h, so we can consider f of minus h is equal to nothing but y0, right, and f of plus h is equal to nothing but y2. So just solve the value here in this particular equation, so just solve it, then you get y0 is equal to nothing but a into h square minus b times of h plus c, and y2 is equal to a h square plus bh plus c. So just add it, both of them, we get y0 plus y2 is equal to 2 into ah square plus 2c, right? We know why the value of c is nothing but y1, then we get y0 plus y2 minus 2 times of an y1 is equal to 2ah square. But from this particular equation, okay, we have got the value of h cube. Here we got an h square value, right? So we'll be substituting it such that 2a into h square into h by 3 plus c into 2h, right? 2 into a into h square is nothing but y naught plus y2 minus 2y. So just we substituting it, get as y naught plus y2 minus 2 times of y1 into h by 3 plus c is nothing but y1, right? y1 into 2h. So to consider h by 3 is in a common term, what we do is nothing but this one multiply by 3 and divide by 3. Then we'll get the value as nothing but y0 plus y2 minus 2 times of y1 plus 6 times of y1 whole multiply with a h by 3. Then the value is nothing but y1 naught plus 4 times of a y1 plus y2 h by 3 whole multiplied. This is nothing but called as an 141 quadratic approximation. Okay, simply to find the value of it, area of it, the general one-for-one formula is nothing but this one. You have to remember this particular formula. Okay, it is h by 3 into y0 plus 4 times of y1 plus y2. Okay, this is a 141 rule to find the area of a quadratic equation approximately. Okay, now how comes a Samson rule come from this particular 141 rule? We'll be finding it out. The Samson rule. Okay, for this one first you have to know about the 141 quadratic approximation formula. Okay, approximation formula. The formula is nothing but given as h by 3 into y0 plus 4 times of y1 plus y2. Okay, now in Samson rule what you do is nothing but, if you consider an example here, this is a graph, this is x-axis, this is a y-axis, right? And this is a continuous function. This is nothing but a 0, right? If you consider a point here as an x0, and this one is nothing but x of n. Okay, it is in a continuous function. Now in the Samson rule what we do is nothing but we'll be dividing this one into parts, subintervals. Okay, then subintervals h is equal to nothing but given as x of n minus x0 by n, where n is nothing but number of intervals. Okay, depending on this one the accuracy will be more n value then more accuracy, less n value then less accuracy. Okay, now in this one we'll be dividing each and every term such that x of 1 is equal to nothing but x0 plus h, then x2 is equal to nothing but x1 plus h, so on would be doing it. Okay, so just start dividing it, the graph. This one is nothing but x1, this one is nothing but x2, this is x3, right? And this is nothing but x of n minus 1. Okay, in the case of 141 quadratic approximation we have taken the three terms, right? y0, y1 and y2. Here also will be considered these terms also, y0, y1, y2, y3, so on. Okay, to y of n minus 1, y of n. Okay, for this one first we're defining the area of it of any three terms. Okay, then we get the formula as nothing but h by 3 y0 plus 4 times of y1 plus y2 plus what you do it again we're finding it for next three terms. Okay, because this one is an x4, this is y4, again we'll find it for next three terms. Then the formula is nothing but h by 3 into y2 plus 4 times of y3 plus y4. Again we'll be considering next three terms. Okay, and finding the area of it. Then we get plus h by 3 into y4 plus 4 times of y5 plus y6 plus so on will be going on, right? Then here also consider 3 terms. Okay, this is nothing xn minus 2. This is y n minus 2. Find the area of this one also. Then you get as plus h by 3 into y of n minus 2 plus 4 times of y of n minus 1 plus y of n. Right? What we are doing? Just dividing the graph. Right? We'll be dividing this particular graph and we'll be finding the area of it by part and we'll be adding it. Right? Now just when you add this one, we get as h by 3 into y0 and yn are repeated only once, so it becomes y0 plus y of n plus 4 times of y1, y3, y5, yn minus 5. So it becomes 4 times of n y1 plus y3 plus y5 so on to y of n minus 1 plus 2 times of nothing but we get as here y2 is repeated twice and y4 is repeated twice, so it becomes y2 plus y4 so on to y of n minus 2. Right, this is general formula of a Samson rule. Okay, now you have to remove this particular formula. The basic condition to satisfy this particular equation is that when n should be an even number. When n is an even number, then only we can form this particular formula. If n is in an odd term, then this particular formula does not satisfy. Okay, always consider that n should be an even number. We're solving one of the problem on it. Now come into numerical integral. Okay, I've noted down the formula. In the process of evaluating a definite integral a to b f of x dx or x naught to x of n f of x dx, and we're dividing a and b into n equal lengths such that subinterval h is equal to b minus a by n. We consider n is equal to nothing but an even number. Okay, that's the basic thing you have to remember. Now how to solve an integration is nothing but by using Samson rule, integral a to b f of x dx or x naught to x of n, okay, is equal to h by 3 into y0 plus yn plus 4 times of y1 plus y3 plus so on to yn minus 1 plus 2 times of y2 plus y4 plus so on to yn minus 2. Okay, where y0 is equal to f of x0, y1 is equal to f of x1, y2 is nothing but f of x2, so on. Okay, and x1 is equal to x0 plus h, x2 is an x1 plus h, x3 is equal to x2 plus h, so we can find the values. Okay, now we'll be solving one of the problem on it. Now come to the question. The question is the integral 1231 by x dx when evaluated by using Samson's 1 by 3 rule on two subinterval each of length 1 equals. Okay, first we understand the question. They are given an integral, right? So integral is nothing but it is given as 123 1 by x dx, which is equal to, we consider this one as integral from x naught to x of n f of x dx. So from here we can say that f of x is equal to nothing but 1 by x and x naught is equal to 1 and x of n is equal to nothing but 3, right? Now again they are saying of two subintervals each of length 1, so they given the n value, n is equal to 2 now. So from this one we can find the value of an h, right? H is equal to nothing but x of n minus x naught by n, which is equal to 3 minus 1 by 2, which is equal to nothing but 1. Here we got the value of an h is equal to 1, right? Now by using the Samson rule we have to find the area of it, right? Now for this one, what we do is now first find the value of an x0, x1 and x2, right? As they are two subintervals, right? So here x0 is nothing but x of n is nothing but 3, right? So get x0 is equal to 1. Then x of 1 is equal to nothing but x0 plus h, which is equal to 1 plus 1, which is equal to 2. Then x of 2, which is equal to x of 1 plus h, which is equal to 2 plus 1, which is equal to 3. So we got the value of this one, right? This is 1, this is 2, and this is 3, right? Now we'll be using a Samson rule. Samson rule, general thing that we know is nothing but integral of from x0 to x of n f of x dx is equal to h by 3 into y naught plus y of n plus 4 times of n y1 plus y3 plus so on till y of n minus 1 plus 2 times of that one y2 plus y4 plus so on till y of n minus 1, right? This is the general formula of it. Now n value is given as nothing but 2, right? So we will substitute the value here. We get as h by 3 into first term and last term. So it becomes y naught plus y2 plus we have only one term 1, right? So it becomes 4 times of an y1. So we have to find the value of y1, y2 and y0. First we will be finding the value of an y0, which is equal to the f of x0, right? We know the value of f of x is nothing 1 by x, so which is equal to 1 by x0. So it becomes 1 by 1, right? Which is equal to 1. Then we define the value of y1, which is equal to f of x1, which is equal to 1 by x1, which is equal to 1 by 2. Then y2 value, which is equal to f of x2, which is equal to 1 by x2, which is equal to 1 by 3. So substitute the values here. H value is nothing but 1, so it becomes 1 by 3 into y0 is 1 plus y2 is 1 by 3 plus 4 times of an 1 by 2. It goes by 2's, right? So which is equal to 1 by 3 into 3 plus 1 by 3. Substitute the value, we get that's nothing but 10 by 9, which is equal to 1.111, right? So answer is option C.